translated mechanics can.
Yeah, maybe someone.
Okay, thanks. Please. First.
For the first question, what is the best way for dynamic navigation generation?
Yes. So they can change the best way because they can we have maybe no way. So that's the best. Maybe the change approach. So we just change the best way to the changing approach.
Okay. When it comes to generation of models and data structures, then I think that we have at the moment a situation where media as a combination of academia and industry work together on models that are for some very specific purposes and try to make them as general as possible to reuse them in different ways. So that's the idea behind CGMR and in that respect they are quite similar. But on the other hand, there are completely different type of models for very specialized applications, like for example evacuation simulation, where you often don't have a network structure for routing and navigation, but you have open spaces and different people coming together. You have agents that are simulated. So that would also be necessary indoor models that are available for this kind of applications, and that are typically not used in that industry we are thinking of. So I think we need to be a little bit more open with these models and have different for different purposes, but being able to convert and map them to each other, both the geometry, which might be hard because one model is only topology oriented, the other one is very geometry oriented, but of course also the semantics. And this is the one side. And the other side is that we see now a lot of very great technologies for getting that data and processing it, and to have a really dynamic model generation. Also, we need to have very highly automated workflows from the raw data generation to the final model. But also here I see a difference between what is state-of-the-art technology in industry and academia, and on the other side there's this new idea of crowdsourcing where they use very low-cost sensor, not specialized tools, but also creating new kind of data. And I think this is maybe one of the future aspects also for the big challenges. How do we deal with that new paradigm of producing, for example, low quality but high massive data point clouds, for example, and from non-specialists, and how can that be integrated in that models? And I don't have an answer to that, but I think this is one of the future challenges.
Okay, number 7, as a check the D for the category.
On the slides.
The material Teflon is okay.
Oh yes, I'm here. Good morning. Sorry you can't see me. For some reason my software doesn't allow me to start my webcam. I have no idea. I hope you can hear me.
Yes, I hear you.
Good. That's good. That's a good start. So yeah, it's a pleasure to be there, even though only virtual. So yeah, I mean obviously dynamics means there's change. Otherwise you would need dynamics. So I suspect that in most application cases, what we actually have is a kind of static model. So I mean the world as it is, the building, the indoor environment, and we really need dynamic situations if something special happens, for example, an emergency or things like that, where things actually start to get slightly crazy potentially. So there might be a fire, and some of the routes are blocked. Obviously, lots of people are suddenly moving on in the same direction. So I think that's probably the most important case for actually having dynamics in a navigation model, because otherwise, well, it also obviously depends a bit bit on who or what is navigating. But if you think of people navigating, we're usually quite okay in reacting to dynamic situations if there's more or less people in the environment. But in these emergency cases, it obviously becomes crucial that the models adapt to whatever changes might be there. And I mean, Alexander already mentioned this crowdsourcing, user-generated content idea, and here it might actually be really helpful to also rely on the feedback of the navigators, let's say. So if someone encounters a corridor that is blocked, it might actually be useful to be able to feed that back into the system, so we don't get a situation if you obviously necessarily turn around, you get these like car navigation systems like to do if possible like a legal U-turn. I mean, if the corridor is blocked, it's blocked. So I think that might be actually dynamics we could and should think about as well. So the dynamics between the model and the user and potential feedback mechanisms there.
Okay. Thank you. And in fact, for the indoor environment, the door-to-door network will be fixed. But in such kind of the open space, the abstract, the point of the interest will be changed. It can be used for the refining the algorithm. I say like this. That's what that's the environment. Okay, how about Trevor?
Yeah. If I could just stick to the modeling side of it, because obviously even the navigation is dependent on that. What we are seeing is that a couple of points. One is that we're finding the convergence of a lot of different technologies is what's driving the application. So the previous speaker mentioned the in-car navigation algorithms for rerouting, for instance. We're finding imagery starting to play more of a role, the laser scanning, RFID on the navigation, Wi-Fi positioning and so on. And what's happening because of all these different technologies that are merging and converging to give a solution is that the amount of data is just becoming almost unimaginable. And we find in terms of the applications that we're okay in terms of the collection of the data, but where it falls short is really on the modeling side. You know, a previous speaker was talking about the ratio of collecting the data to actually then modeling the data, let alone to actually start using the data. And in some instances, we find a ratio of 1 to 10. So you can spend an hour or a day collecting the data, and the user would then spend 10 days in the office trying to make sense of that and actually creating a model. And once that model is created, you're assuming that the end user of that data has got the tools to actually use that model. So this is where we think, we find a lot of the challenges is that we sorted it out on the sensor and the technology side, but now the application of it in a usable format is very difficult. And what's driving that difficulty is the amount of data that's being collected because of the multiple technologies.
I think also one of the challenges would be also getting the correct relevant model that we've got up to date. So when it comes to sort of the navigation side of things, we've got your sensors to make sure that they are using an up-to-date model and having that dynamic sort of from the field to the system is using it.
How about geomes? Sorry, maybe you're waiting for a second question. Already. Okay, let's move to the second problem about the optimal routing and navigation. What's a challenging approach for contextual routing and navigation? Okay, Alex.
Well, I like the idea of contextual routing, of course, in the outdoor situation. There has been some research on it, and of course you can adapt the navigation routing to different situations that need to be sensed by some sensors. But when we look in indoor, then we know less at the moment about what are typical sensors, what are the and situations, what are the tasks here. And we need to consider that context is more than location, so we have to consider much more potential influences, and the current models don't care for that, or they don't consider this information. So we need to integrate the indoor models that's being generated and the standards with a more general context models, and even for the outdoor situation, these context models are still not very stable, I would say. So it depends, of course, also on the use cases, what type of adaptation or you want to do for routing, or what kind of context information you want to use. And so it becomes a sense of usual data integration problem that what can be used. And in the one of the solutions in the former time was that we want to have also context adaptation to the user. So we wanted to know a lot about not only the environmental situation and the location, but about this user's interests and behavior and so on. And there is a time where privacy comes into place, and which might be a problem in some use cases. And what I would like to see are algorithms that do adaptive routing and taking context into account, but without being problematic in terms of privacy. And I think this is still a challenge.
Yes. I see yesterday in the presentation about the geofencing. I say such kind of technology can give us the contextual service, as well as today's there is an example about the museum's location. We can record the visitors' behavior, the experience, and then next we can use it as a knowledge for the service. So maybe the contextual in the indoor is more important for the personalized. So maybe we can record many knowledges. So how about the vocabulary?
Yes, okay, so I agree with Alexander that, again, with boring, that I think indoor spaces are a bit more special than outdoor spaces in the sense that the user groups are often more specialized or more diverse in some sense. So I mean, if you think of the venue you are in at the moment, I mean, you as a participant have a different view on it as, let's say, the people doing the catering or the cleaning or things like that. So and you'll probably also have different spaces of the venue that you can access compared to the catering people and the cleaning personnel. So I think it's really important that models account for these different views, these different functions potentially also. So what is the lecture hall for you might for the cleaners simply be the largest room to clean, so they don't really care that lectures are being held there. So and we can find other examples like this. IT people often have a different view on a building compared to other people. So I think it's really, really important that we account for these, let's say, different ontologies or different conceptual views on a space, which then also obviously translates to differences in how we navigate or interact with these spaces. And yeah, as I said, there's also these differences in accessibility, in what we're allowed to, or where we are allowed to go, where we're not allowed to go, which obviously has influences on routing and navigation as well. So all this, I guess, needs to be somehow captured in our underlying models in order to allow for these contextual or personalized or whatever you want to call it, routing and navigation approaches.
Yes, I see also there is important, such as in the shopping mall, we can provide two kinds of the service. One just for the public, the people for the shopping purpose. Maybe the position and accuracy not very high, but another just for the facility management. We have to provide more accurate positioning as well as the location service. So maybe the same environment for depending on the different users. So we have to provide the accuracy, the reliability, as well as the usability at this. How about it?
Yeah, as I only view knew I was going to be on this panel 10 minutes ago. I didn't have to prepare properly, but I could maybe contextualize it in, again, from a technology point of view, the concept of navigation and dispatching workers from one location to another because it makes more sense. And by doing that, getting them to navigate to that point and being route optimal is an established technology like outdoors. And again, applying that to indoors, the challenge is going to be on the location side of it, but the algorithms and the methodology of getting people optimally dispatched is important. But I'd like to tie into that as well. Why are you getting them to move from point A to B? And in order to make those decisions, what actually you need to understand things in a construction environment as to what is the skill set of that individual, what tools or implements does he have, and to understand that that's required at another location in that model. So the point I'm just trying to make is it's one thing navigating optimally, but you also need to have that infrastructure of that surrounding data in order to make that decision to go from A to B. So it's not just the location or positioning point, it's that information wrapped around that individual asset.
Yeah, so I think from the routing and navigation side of it, one of the challenges is going to be on the on reaching the environment that you're going to be navigating a particular sensor through. So you're going to have, it's going to be dependent on the type, the accuracy and the type of sensor that you're trying to use. You're going to have different in a building environment where you're going to have large open spaces, or then go into tight spaces. You're going to maybe have different technologies that would work better in those different environments. So you may be able to, if you're wanting a high accuracy positioning, you may only have the technology that will work in certain areas of the building. So yeah, so it's going to put a way up between your sensor, your accuracy, and what's required for the region.
Sissy?
I want to comment a little bit on this topic about the position of the accuracy. Actually, everybody somehow thinks about positioning, localization, really like outside, about having a point somewhere, and you try to find out what is the accuracy when you are localized. But actually, indoor, we always need to have the same type of positioning like outside. Actually, indoor, we want to know in which room we are. We want to know in which part of the room we are. For example, if somebody wants to, if I want to explain to somebody that I'm now in this building, I'll say I'm in this building, I'm in this room, and I'm exactly in this section of the auditorium. So it doesn't matter anymore what is the precision. It's more important how to identify in which part of the space you are. And depending on how big is your space where you want to be identified, then you might think of specific technology that can localize exactly in such an area. And it comes very close to the picture that the line yesterday showed about for different purposes, different spaces. So first you decide in which spaces you want to be localized with what kind of accuracy. If you want to do some maintenance, you need to be very precisely localized in this area. So this area there around this management of the whole of the installation, you have to know with accuracy about 1 meter. But if you want to say, okay, I'm here in this room, it's enough to be 10 meters. So I think we have to a little bit reconsider our idea of localization that we have outside. Outside is always kind of how accurate. While indoor, accuracy depends very much on the semantics, what you want to do, how you want to be within, recognized somewhere in the space.
I agree. I say a challenging project for the indoor route plan or wayfinding is about the two kinds of the mode. One just popular, maybe we can choose the shortest way. But in emergency case, the shortest way not so safe. Maybe you have to choose the safety. So we call it maybe a kind of the location where the we're finding a route plan. You have to consider the obstacle like this. You have to consider the peoples cannot result in the crowded. So maybe the routing and the navigation have to use a different like this location where all the users are oriented like this. Okay, let's move to the third question, and then we can ask the audience to class. The third problem about the let's say the classical one, the seamless navigation from the indoor to outdoor, from outdoor to indoor like this. So what's the challenge approach for seamless navigation? Okay, please.
Okay, seamless navigation between outdoor and indoor. I think sometimes it's getting hard to distinguish between outdoor and indoor. There's in urban areas an increasingly mixed zone where you go to tunnels and over bridges and in historic shopping malls and you're inside and outside. And I think in that occurrences you want to have a seamless user experience, so you don't want to see any technical things happening and have to do something for having different modes of positioning and navigation. And there you need some seamless navigation in terms of the positioning needs to be seamless and the user interface needs to be clearly the same. Then if you have very specialized applications, like for example if you're going to a museum, then you might have a specialized application for that and download it, or if you have a construction task, then of course you have your specialized application. Then it doesn't need to be that seamless, I think, at least not from the user experience. But what we don't know yet is what is the best way to, if it comes to the user interface, how it should be seamless. Do we really need a 3D representation all the time, or do we need more abstract representations like we used to have in digital or something? And that depends probably also on the task at hand. So I would say the biggest challenge is identifying, but providing technical means for localizing and having that seamless experience in that mixed zone of the urban channel.
Okay, here we always want to classify the indoor and outdoor. Okay, of course, sometimes the indoor environment not the center open space to the outdoor. Here we just specialize in a closed space like the subway, like the tunnel, so very close space, and we have to use different positioning technology and different navigation measure. So like this, because this is quite different from the outdoors mode. So what's the I think critical problem to provide to the users really seamless. So I say this is the challenge. I think about the Catherine.
Yes, now in this half of what Alexander said, there was a slight drop out, so I apologize if I repeat some of what you may already have said. So I also agree that that's what I still got. I also agree that these mixed spaces, so where it's not quite clear whether you're indoor and outdoor, are actually very interesting, but maybe not the focus of that question at the moment. So I think there are two levels, or at least two levels, of where we can talk about seamless navigation. So one is the more technical aspect, and one is the communication aspect. And on the technical aspect, I think seamless navigation is actually really important. So in the sense of that I have seamless positioning. So I, as the user, I don't have to care about whether the system currently positions me with, let's say, GPS outdoors or something like Wi-Fi or whatever indoors. And there should be a smooth transition between these two. And there's obviously also the data issue between outdoor data and indoor data. So there needs to be a clever, smart, useful way of if not integrating, at least connecting, let's say, a building information model with some GIS data or whatever that you want to do in that space. So I think these are the technical aspects there are really important in terms of seamless user experience. When it comes to communication, I'm not actually sure whether seamless is really important or useful, because the way, I mean, there's certainly quite a few similarities, but the way we communicate about more confined, less open space, smaller indoor spaces compared to outdoor spaces, I guess is quite different, and it's potentially also not only in terms of language, but potentially also in terms of some graphical communication, maps, 3D, whatever. So I mean, there needs to be a useful transition that might not be too abrupt for the user, but I don't really think it would hurt if the user actually had a scene there, so really notice that, okay, I mean, it's usually quite obvious, but okay, now I'm outdoor and my system actually realized that as well. So I'm yeah, on that level, I'm not really sure whether seamless navigation is really desirable.
Just from the technology or the sensor point of view, to generate a position, I think that's a challenge we see in other environments as well. For instance, on mining, especially in open cast mining and underground, the challenge exists where you use GPS when you have a visible view of the sky, but when you go up to the high wall, for instance, complementary technology starts taking over. But I don't think we're far off, you know, the discussion on accuracy and so on, and the relevance in terms of the application of the position. I think if you look at where, especially positioning technology on cellular handsets are going, I don't think we're far off there. If you start in terms of positioning in many indoor environments, you know, the fact of the matter is we can, if you know where to look, find the GPS satellite positions indoor. And if you've got some complementary technologies that will add to that, it's easier to find that signal and use part of the solution for the position from the GPS. And then you've got your cellular, but I think that's going to be a big driver, is the handsets, the cellular, in terms of positioning, just because it's so prevalent and in the industry. So, you know, if you could solve that, moving in and outdoors is irrelevant if you're using the same system to position yourself.
I think also it's just getting the different technologies and stuff on the same system. So when you're going from outdoors using GPS to going to using other technologies, if there's no sort of both working on the same system, so you have reference systems, so you don't see any big that seamless transition between going outdoors and indoors, and not sort of noticing that you have switched.
Please, everyone.
About the outdoor and indoor difference, it's always outdoor and indoor, but maybe it's more interesting to look at it as, especially for navigation, pedestrian navigation and other sorts of navigation in terms of use. Because as a pedestrian, I want my system to be, I want to be able to walk through buildings and then come outside and have a continuous positioning and navigation system. And for car navigation, obviously that's outside only, but I think we have to move from the difference between outdoor and indoor more to pedestrian and non-pedestrian, which is more outdoor related. And then a remark on what Cici said about the semantics and the accuracy indoor is more linked to the semantic positioning. I think that's also the case in outdoor, but as you're navigating outdoor, you also link to the street level and maybe an address, but it's more on a higher level of detail in a sense. And obviously, there it's used from you get your positioning, your accurate positioning more easy than indoor. So I think the semantic, the link with semantics outdoor is also there, but it's just easier to link it with accurate positioning than indoor. So I don't know if you understand what I mean.
Shall I say something?
Yeah, sure.
Yeah, actually outdoor, when the people are positioned, actually you don't, you have the semantics, but you don't pay that much attention to the semantics. And Now the applications, they don't pay that much attention to the semantics. They give you just the position. And you can see where you are. When you are driving on the road, actually you are automatically snapped to the network. You are not allowed to go outside the network.
But if we were able, imagine we were able to accurately and instantaneously position ourselves with XYZ coordinates in a building, we don't care anymore about the semantics either. If it can show us we're here on the map of an indoor building, it's similar. But because that's not available at this point, we turn to the semantics. So it's
I'm not convinced because outdoor somehow we have well-defined streams where we can walk. We have the streets, we have the pavements. When we are in the mountain, we have some paths and these kind of things. Indoor, actually, we move much more freely, and we can identify ourselves in open spaces in different ways, not related to a corridor or a street or how to say it. We don't have this well-defined paths where we can walk on. We can be sitting somewhere, and we still want to be localized in the area where we're sitting. We want to be navigated to some items somewhere in the shopping malls or these presentations from yesterday. And again, there, you want to be localized within this area, what we're looking for, more accurately than in other spaces where you don't care that much how you walk. So we try to create the networks actually indoor to be able to simplify our job and make it similar to what we saw outdoor. Right? Yeah.
Just riding on that networks, I was thinking about, well, actually I have questions, but it's kind of hard to just ask without creating context first. The networks you're talking about and the differentiation between indoor and outdoor, keep saying we want seamless, transformation or movement between indoor and outdoor navigation. Is it not maybe a good idea to, or maybe it's already been developed, to try and just forget about indoor and outdoor and just create one technology that will work with both? But obviously there's a set of challenges, but I've seen a lot of presentations in the last 3 days, and even though it's a 3D indoor conference, we had lots of focus on floor levels, and then usually there's a vertical transition between the 2D environments with a staircase or a level shaft. But if you take an environment like an airport, we typically have this long, slowly, gradually sort of descending ramps. And at which point are you now at level 1, and at which point you cross over to level 2? It seems like one floor level. And is it not maybe a good idea to change the model from 2D polylines snapping to a floor rather than to 3D polylines? Like, think of it almost as flight paths. Even though there is a floor, if you could now, after you've solved the positioning indoors problem, or it's a different problem to solve, and if you've solved the data acquisition and modeling problem, and you've now created your network inside the building that you like to use for navigation, and you've got your shortest path calculations, when you actually start navigating and you bring augmented reality into it, isn't it maybe the most efficient way? Because then you could have augmented reality with, heads-up displays are quite common now. It's in automotive vehicles, it's in aircraft, and now with the Google glasses and stuff, it's a few years and it's going to be, the resolution's going to get there, it's going to be more commercially available. So you say how much work is basically done in this field, and how long is it before we, because if you think about it, we're starting to develop vehicles now as well that can fly for commercial use. It's not really a technical problem, it's more an administrative problem because the licensing and crashing and things. But building a vehicle that can fly, it's a small chopper can do it. So we're going to head that way eventually, I think. So then if you have a navigation system that can handle that sort of navigation, then it will work indoors as well, I think. Once you've set up your flight paths or your navigation network, then it's simply calculating the shortest route and then putting it up on a heads-up display.
Yeah, but that's the point, though. What kind of network you are calculating the shortest route? You need to have some kind of
We use 2D
algorithms.
we use 2D polylines with nodes and edges
Yeah.
at the moment, a network like that. So why can't we extend that to a 3D polyline network?
Exactly, but how do you extract them? From what kind of, from the geometry? How to create the networks? That's
Oh, it's going to
exactly
be
the
a
point.
manual or semi-automatic process at
But
this
the
point.
point is exactly to be automatic. That's the, it's going to be,
Well, if you, maybe I have the, there's a building grammar that once you understand how a building works and you've got a model that's automatically created, it's not automatic yet.
yeah.
There's going to be certain assumptions that the software can make that this is a corridor protocol, so it'll be a polyline with some nodes on it. And then you're going to need some user verification.
But that, you're coming very close to the point, exactly. She defines the spaces and what is the structure of it. So this is what how to say, this was my idea as well. So we have to be able to identify the spaces and on the basis of these spaces to derive the network on which we want to do the navigation for different purposes.
Then you need a software platform in which to define it.
And this is one very nice approach. You have some kind of rules and grammar, and you try to subdivide the building to be able to find out what is the internal distribution of the space, to know how the spaces are connected and how to navigate this droid within the free space.
But our current navigation platforms, just your Google Maps and that sort of stuff, is it the language that drives the background? How easy is it going to be to upgrade that language to sort of a 3D environment, or do we have to write something completely new? And if that's the case, how much development is being done?
About three-dimensional, going from 2D to 3D.
Yeah, so flight paths and things, there must be something already.
Yeah, we are doing also at our university some experiments with voxels, for example. Identifying, subdividing the space into voxels, and after that, trying to define a shortest path within the
Voxels like a
voxels.
3D pixel. Or
3D pixel. Exactly, yeah. And you can apply all kind of subdivision also in 3D, similar to 2D plans. But now this is just research, just experiments. I know several groups that are doing this kind of experiments at the moment.
I would have a comment. Outdoor navigation is very mature. As we all know, we use it on an everyday basis. So coordinate system, 2D maps, 3D maps. They offer, for cars or for pedestrian also. When you use Google for pedestrian, we can go in the downtown of the city and narrow streets that look like corridors in a shopping center. You arrive to the center place, which is all open, which is maybe similar to a larger area in the shopping center. So my point is that I think that we should make a big effort in finding all the similarities that is already implemented in nature and outdoor, and finding the similarities in indoor, and see how we can expand the outdoor ways of doing things into indoor, like coordinate system. I mean, coordinate system used for outside, unless the precision lacking maybe sometimes, they can be used for inside as well. And then add the elevation to know maybe on which floor you are. There are 2D maps for externals. There are 2D floor plans for internal. There are 3D maps for external that let you turn right and then you see then you could use the same approach internally. And then when there are differences that justify to have something different, then add those as special cases.
Yeah, right. But in a way, for our door, we are going with the network. That's the key point, actually. We have network defined everywhere, on the streets, on the pavements, everywhere we can perform some navigation, there is a network.
Yeah.
So the question that we have to answer for indoor is, what is our network?
How do we generate the network?
How do you generate the network? There are many different approaches.
Oh, yeah.
Yeah. So which is more efficient than to work also in 3D?
But not,
and not only for walking, but let's say also for driving or for flying in buildings.
Yeah.
Yeah.
I include the availability and the continuity in the positioning, seamless positioning in the seamless navigation. So I try to set up the positioning system mixing, as you mentioned. But I have problems actually I can get position data out of the environment and in the environment, but sometimes we lost the position data in outdoor environment and indoor environment. So do you have problems in your projects or studies, and do you have a good idea to improve the availability and the continuity in seamless position, seamless navigation? This is my question. So I include the availability and the continuity. So sometimes we lost the position data in the environment. If we have a good receiver, but we sometimes we lost the position data in some places.
In fact, in China, we are now just have a big project. We got central government support, just based on the compass satellite system, and then we can provide the indoors positioning service more than 1 meter accuracy. Just we could really seamless from the outdoor to indoor. Just of course integrate different indoor positioning technology, and we can provide the standard service to the public. This is also a project, and we can just hope in the 3 to 5 years can import to USA, to the Europe, and cooperate with the GPS and the Galileo similar system. So we just get into the indoors position, just continuity and reliability, similar to your operation.
What technology, sorry, can I ask, what did you use indoor? What technology did you use for positioning indoor?
Actually, I don't have a good system, but I have an idea to improve the availability with the positioning system mixture.
Yeah, it comes down to affordability as well. There are technologies today that can seamlessly go in and out, but it's very expensive. If you start thinking about IMU technologies, encoders, GPS, and we have a system, a trolley-based system that you can push. It's got GPS and other positioning, and as you move in the building, you can even go in an elevator and go up. It uses encoders and IMU, which obviously the accuracy degrades over time. But you can recalibrate it, but it's a very expensive system. And it's definitely not portable, but you could map a building like this very accurately and in 3 dimensions very easily. But it's not a practical solution right now. But one thing we do know is that that technology, as I say, will get smaller, cheaper, less power consumption. We'll be able to do it. And I really think that's where the handset, the cellular industry is going to drive that position.
So it's for professional choice.
Thank you. Question for the panel. When listening to the discourse on navigation, what people talk about, you hear a lot about the models, you hear a lot about the standards, but shouldn't there also be some discourse on the methods for testing the models and standard. It's going to go into a real world where you're actually taking that model that you've designed on your computer and applying it in the real world. Shouldn't there also be some discourse on how to go about testing whether these models actually work? Having the protocols for testing, whether it's a voxel model or a network model, having a separate protocol for actually testing these.
I mean, research environment, of course, you always should evaluate what you're doing, and often you fall short of that because of time restrictions and so on, and you do some user studies and some other things. But it's of course a core component of proving that your model or what your application or whatever you did is right. But I don't know what standard answer you would like now for that. But I think the real user test is when it comes from transferring the research ideas into commercial applications and real-world usage, because then they need to be robust and actually do what they want, and that's the ultimate testing. But in a research project, you always have this evaluation part, but you always probably can only do a tiny part of what you want to evaluate because of that restrictions.
Okay, I have an idea. You can see ISPI is other work group just have a benchmark test, and it's very good for the in-purchasing can data present where the first city building. So I say our group can do such kind of thing. We can choose the typical buildings or environment for the algorithm for the data test. Maybe it can be a benchmark that ISPI 7 groups work.
Maybe if I can add on to that, if you go to look at the software development environment, the testing is a very big component. So writing the software is not just part of it, but you also have a testing regime for that. And there are standard methods for testing your model, and testing data and software developers will go through that. Maybe you think that something like that might be necessary for us in the modeling?
Depends on what you want to test. So do you want to do real testing so that the system works, or do you want to evaluate if it's effective and is it user friendly or something like this, which is quite different story.
The ultimate test is going to be once it's commercialized and being used, and we've got to be careful to, as with let's take in-car navigation, as long as the design of the system takes account of the actual use and actually leverages off. If you look at a map being created or network outdoors, the good systems nowadays will actually use the data that's being collected by the users to update the model for streets, etc. And I think that's rather the approach to get to a standard indoors as well. As the system's being used, you can derive intelligence from the use of the system. There is a corridor, that corridor is now closed, or there's been an add-on to the building. But if you've got that loop back into the model again, that's the quickest way to get to the actual representation of the real model out there.
Okay, the time we come to the summary. I say, I hope the panel member can tell us the biggest challenge in indoor development and navigation in the next several years. And first of all, ask the Thai brother, maybe is he on?
Yes, I'm still here. Yes, so I had slight problems following the discussion from the audience, but okay, anyway. So yes, I mean, in terms of challenges, from what I got, I think you got into the discussion already during the last couple of minutes. I think if it comes to modeling, or to modeling, especially indoor, outdoor, and the transition between these things, I think the most important thing in some way is to be able to sense with a high confidence, but as a high accuracy, whether a user or the device you're positioning is actually indoor or outdoor. And accuracy here doesn't necessarily mean that you need centimeter accuracy of your actual position, but it means that you shouldn't accidentally place someone indoor who is actually outdoor and vice versa, because I mean, apparently, there's been recent studies in Canada by Scott Bell, for example, where let's say if you're positioned and you're actually indoor and the position is 3 meters off, that's all right. You can cope with that as a human being quite easily. But if 3 meters off means you're actually positioned outdoor, even though you're indoor, people get confused and slightly angry at the system because that's semantically obviously wrong. So I think this really, and that obviously especially holds in the transition areas where you're close to being either indoor or outdoor, coming from the other side. And I think this is really crucial in order to get a useful and a user experience and some experience the users actually accept. So they apparently and obviously have a hard time to be misplaced between indoor and outdoor. And I think once we sort of settle this, or this idea of seamless navigation or navigation that actually gets us from indoor to outdoor and outdoor to indoor, should be doable in a way.
Okay, Sandy, please.
So in my mind, we can solve the positional problem. There's enough, to Alain's point, there's enough correlation between what's happening currently outdoor that it's going to be easy just to translate that to indoor. You know, I think the big difference between indoor and outdoor, and one should be careful not to try and distinguish too much between the two, because you then have the danger of losing some of the advances that's made in routing and navigation from outdoor. I think the biggest difference indoor is really the third dimension, which plays much more of a role, because moving from this floor to the next and up the staircase. But if we can solve that positioning issue, it doesn't really matter how you describe it semantically or how you represent that. I think that's the key challenge. If we can overcome that seamless navigation between the two, a lot of other issues will be solved after that.
Well, I picked 3 challenges. One is a technical one for the colleagues at Trimble. I want the nice machine you presented in 2020 in my smartphone.
You're busy with that one?
You're busy with that one, and we've seen yesterday the things that are 3D, derive 3D point clouds in price range about less than a smartphone cost. So this is maybe not even a challenge, but this is how technology moves forward. But then we arrive at a new challenge, because then we have magnitude bigger of larger point clouds, so that derived geometry problem will be solved. But then we have the semantics problem. What do we do with all that things? That is maybe my second thing. When we have 3-point cloud as mass market product, how do we deal with that, and how can we make that usable in and the last thing is maybe more really scientific or usable, because we talked yesterday that the user interface is very important in 3D, and that is a sort of still unsolved problem. And of course we don't need 3D in all times. I think the best visualization for indoor modeling are still the traditional floor plans, because when you want to visualize a complex route through a building with semi-transparent walls and things, you get lost. You don't really can do that at the moment in a good way. If somebody has a solution for that, that would be good to have. Because when I have a 2D, I can have a map and it shows my route, and I nearly know where I have to go. But in 3D, in a really complicated building, that might be much bigger. Is still a much bigger problem, I think. So that 3D visualization, if it's needed, when it's needed, that is in indoor not really a good solution available.
I think also the biggest challenge is obviously the sensor technology. What's going to be the sensor technology that's going to take us through that seamless transition between indoor and outdoor? There's a couple to choose from at the moment. And then also for the navigation, we've been in sort of a 2D world for quite a long time, and we've got a lot of 3D infrastructure that we need to convert to 3D at the moment. So it's going to be building up that current 2D database that we have and building that into a 3D environment to be able to create these 3D networks that we wanted to use for navigation and stuff.
Okay, I see to the 2020, the users of the application not only our human beings, maybe more and more robots will be our strong to serve us. So what's the new generation of the maps, including outdoor or indoor for a robot? I think maybe it's a big challenge, not only for the human beings. So that's my opinion. Okay, thank you everyone for the time and with other audience. So close this kind of discussion.